Okay, now we get started. This chapter we are going to talk about correlation and couplers. Okay, we talk about correlation and couplers. Let's go to the PowerPoint slide we have. Okay, correlation and couplers. The first we wanted to introduce the concept of correlation. Okay, remember we talked about the risk and return of a particular stock. Okay, we measure that the risk of the portfolio using standard deviation, and we use the expected return to measure the stock return. So this is we talk about here. So is the coefficient of correlation between two variables is defined to be the expected return of the two variables minus expected return of each variable, the product of expected return of each variable, and divided by the standard deviation of variable 1 times the standard deviation of the variable 2. So basically, you see the numerator. This part is called covariance, and this is the standard deviation at the product of that standard deviation is denominator. So that's how you calculate covariance. So the covariance that measure the relationship between these two variable. So we take that the square root of the variance. Okay, the square root of the covariance is called correlation. So how you get a correlation? The correlation is that the square root of the covariance, that is your correlation. Okay, the correlation is that the square root of covariance. Okay, the square root of covariance. So when you get the covariance and you take the square root, that's a correlation. So the correlation, they could be, is going to be between -1 and 1. Okay, the correlation, when you calculate the correlation, it's going to be between -1 and 1. So if that is correlation, so we use a Greek letter. So the Greek symbol we use is called rho. So you can, okay, that's a correlation. The correlation is we're using Greek letter equal or like to 1. Okay, and but is going to be -1, and then you equal or greater than -1. Okay, if the correlation is equal to 1, we call them perfectly correlate. Okay, perfectly correlated. If this is a -1, it's a negative perfect. Okay, perfectly negative correlation. Oh, this one we need to change that symbol. We're using rho instead of p is not okay. Okay, if the this one the rho is equal to okay this one if you have this rho equal to 0, okay, let's say this rho equal to 0. I mean no correlation. Okay, these two variables has no correlation. Remember, if you want to have a good portfolio, you don't want those variables to be positively, highly positive correlate. Okay, and so if for a good portfolio, okay, we want the rho, which is a correlation. If we want that correlation less than 0.5. Yeah, if you see that the correlation between these two variables is greater than 0.5, okay, that's not good. Okay, for a good portfolio, we want the correlation less than 0.5. Okay, so we have another concept is called dependence. Okay, or if this is equal to 0, no correlation. Also, we call the two is independent. Okay, independent. So we or no correlation, or they are independent of each other. Okay, and so another concept we talk about is independence. So the two variables are independent if the knowledge of one does not affect the probability distribution for the other. Okay, so basically you can see if you see the function, the probability distribution function of variable 2, conditional 1, variable 1 is still the same of the probability distribution. Okay, right? It's the same. Okay, so that's we talk about. Sometimes we know that these two variables, they have a linear relationship, but sometimes this variable is not a linear relation. So basically, what I'm talking about is independence is not the same as zero correlation. Okay, they are different things. That's why later on we introduce the concept as couples. Okay, and for example, zero correlation, suppose variable 1, okay, is -y, 0, or 1. Okay, equal likely we have that probability distribution. And so if variable 2 is clearly dependent on variable 1 or vice versa, but the coefficient correlation is 0. So that could happen. So typically we can see the dependence could be these different types. Okay, so linear, or they have the V shape, or they smoothly curved. Okay, we can see the relationship between x and the expected value of y. So there's two variables, a variable x and y. They could depend each other with different type of shapes. Okay. Okay, so we wanted to, when we have this correlation, so we wanted to do is that first we define x variable return. Okay, remember we define the return of a daily return is going to be the most recent value minus previous day divided by the previous day. So the correlation, okay, correlation is going to be the covariance of these two variables divided by the square root of the variance of x and the square root of y. Okay, so the first, we can get the covariance, okay, the covariance of these two variables. And then we estimate the correlation. We can, same method we used from chapter 10. One is called equally exponential weighted moving average. And as another one, we can do as a Gauge model. Okay, we're using two. This is going to be your homework or assignment. So using both way, okay? Exponential weighted moving average and a Gauge 1-1 model to estimate the correlation between these two variables. How are we gonna do that? I will show you an example. This is what we typically do, okay? I'm gonna upload this file, Blackboard. Okay. For example, we do the price. Okay, we have the price, the date of Australian dollar and the euro. Okay, the foreign exchange rate of Australian dollar and the foreign exchange rate of euro. So we see this one is asset A, this asset B. Whatever you can do is you can use a different asset, or you can choose two different stocks. Okay, this is where I got the data. And I got the data from FINA, Yahoo. I suggest you to use real world data. Okay. Real world data. The real world. Okay, the real world data is yeah. Let's say in market, we go to market. We go currency. Okay, this is what I choose. Is I choose euro. Okay, I choose euro, and then we have okay, we click on historical data, and I choose the time period. Okay, with euro, we choose from. Okay, this is a 01. Okay, the first day in 2019, and to the end it is 12/31 to 2019. So we choose that the exchange rate of euro for 2019. So we click on that. Historical price, use the daily price, attach, apply. And then when you do that, you apply and then you download the data. Okay, so that's data I download. So I can show you the data. Okay, here. You can use a different data set. Okay, it doesn't matter. Just the purpose of what I'm doing is to show you how to do the correlation estimation. Okay, let's do this. Okay, this is the data I collected for Australian dollar and a euro. So collect 2 series of different type of data. Okay, so, so using euro, and also you can use Australian dollar or some other currency. Okay, this is the euro, and maybe you wanted to British pound, right? You can use it's a Chinese currency, or you Hong Kong dollar, or Indian dollar, whatever. So you just choose 2 different ones. So that's fine. Okay. And I put all the data right here. Okay, column 1 is Australian dollar, column 2 is euro. Say all the way down. Around like a 200. Okay. And the first one you do is to calculate return of Australian dollar. So you calculate return, remember, so you can 2 different way, okay? And the one we do, remember this is asking you how to do the return. Use the xi minus 1 divided by xi minus 1, okay? Or you're using the one we call the ln. So I'm using the ln function as ln. This is B2. It is go to ln. Okay, this is B2, B3 divided by B2. Okay, you can use the ln. And when you do that, and then you will double click, the function will be there. Okay, or you're using the function we have in Excel in the PowerPoint slides, 1 divided by B2. Okay, either one. Okay, that's fine. Okay, when you do that, you can click on that, right? I'm thinking using ln is more convenient. I just using ln. Okay, divided by this. Make sure, so if you calculate return using ln and then another stock, another asset B using the same, okay, the same way, okay, we do the same. Okay, now we do, we calculate the variance, how to do the variance, equal to, okay, this is the return of A times the return of B. So that's this is the first that you calculate. Remember, so this is the one we called okay, this is the covariance. Okay, this is the covariance. The covariance is just a calculate return and times the returns of A times the return of type B. Click on that. And then you square, okay, the square of the return A. Remember, this is the variance. Okay, A. And then you click on enter. And then you square return of stock B. And you square. And then you double click. Okay, so now you can see this is the covariance, and this is the variance of stock A. This is variance of SIB. So how you get a correlation? Are you gonna get a correlation? The correlation is the covariance divided by the square root of the variance X times the square root of variance Y, right? So we're gonna see how you calculate the correlation. Okay, So we can use this function. Okay, we can get to the correlation. Okay, the correlation we do is, okay, this is how you could do the correlation. So using this, you take the average of all this. Okay, this is the covariance. Okay, you take the average. Okay, you do equally weight, and you select all the variables on the top. Use all the numbers. Okay, so you take the average. Okay, take the average, and then you do the same thing for the other two, right? Take the average. Okay, and then you do the correlation. And this two, how you do the correlation? The correlation is going to be the covariance. We're using this formula. Okay, divided by square root of the variance of asset A times the variance of asset B. So that's your correlation. Okay, so the correlation you have is this number of these two stocks. Okay, this two, you can see what I mean is that Australian dollar and the euro are highly correlated. I use around 0.5. And okay, so there is another way we can do is doing the covariance. Okay, we calculate the covariance between these two. We can using the function is called covariance. The covariance of the return of stock B of asset B and the return of asset A. So you can do covariance or using the correlation function. Remember, so you have a correlation function, right? The correlation, and you choose the return of these two. Okay, the return, right? This is the return of these two. You need to select different, okay? You select this one, and then you do one and this one. Right? Okay. We can do the correlation. So you can see you got a correlation, right, between these two. So all using the correlation function. Okay, so you can get a correlation. Because we do this, okay, this we need to select that. Okay, see, we have a correlation. So let's say we select the correlation of returns A. And then we select return of B. Okay. So we have the correlation, right? So you can see that we got the correlation for similar, very close to the one we did separate using this function. So Excel, they have a correlation function, so we can calculate the correlation. Okay, so you can see that that's typically we did before. As the reason is this is weighted equally, weighted equally. Now we do is using exponential weighted moving average. So this is going to be goes to our dynamic process is now going to weight equally. So remember the equally weighted moving average is that we have given this more weight. So the first one is going to be Okay, this is the correlation. We're using the covariance for the first one, the same. Okay, make sure the second one we're gonna use is going to be this function. Okay, this is going to be the covariance is equal to lambda. Okay, this is the first one, the lambda. Okay. Okay, so we have lambda, and then we do this is a lambda and times the covariance of previous period, and plus 1 minus lambda times the return. Okay, the previous period return times 1. So we're using the lambda, so we assume we have a lambda. Okay, whatever the number you got here, so you don't have to worry about that number. And later on, we're gonna maximize that. Okay, this is lambda. Okay, so here, so it's going to be lambda. Okay, this is the lambda we got here, Q1. Okay, now you $ the Q1. Okay, plus times I3. S3 is the previous period variance. Previous period covariance times 1 minus lambda times, okay, this is the covariance, the return of the product of the return of the two assets. So that's going to be F3. So F3 is the, okay, F3, I will show you this part. Okay, X n minus 1 times Y minus n1. Okay, so that's for the second time period. So we got here, so we click on enter, so you can apply the formula all the way down. Okay. Okay, now is using exponential weighted moving average to estimate the covariance between A and B. And with same thing, we do the variance of A. Okay, the A, okay, the first one is equal to the variance squared. Okay. Okay, we have the variance squared, G3, and the second one, okay, is going to be the same for this one. Okay, we're using the same formula. This is lambda times G1, G3 plus 1 minus lambda G3. Okay, so we have that using the same formula. And then the variance of B, we're using the same formula. Okay, all you got all this. And then when we get the log likelihood of this variance A, remember the log likelihood is minus ln G3. Okay, we have this one, minus G3 divided by J3. So which is the ln likelihood estimation. So we used before and in chapter 10. Okay, is this one? Okay, this is the formula 10.13. So that's the to estimate as a long run variance minus the square root, the square return divided by the long run variance. Okay, or do all this same thing for A and likelihood of the B. Okay, this is a B. And okay, so you have A and B. Okay, both of them take the log likelihood and then you sum them up. Okay, this is your sum or likelihood of these two columns. Okay, and then you do solver. So we have data. So you choose a solver. The solver, you maximize the sum of likelihood. Okay, it's maximized by changing this is a Q1. Remember, this is your lambda. By changing lambda. Okay, so we change lambda. Okay, you subject to, you add this one. Okay, subject to this lambda less or equal to 1, but greater than or equal to 0, right? So you have this is subject to the constraint, and then you click on solver. It will give you the numbers of lambda. For example, we have, we just choose whatever the lambda is, like 0.8. So now we do the solver. Okay, maximize this lambda is subject to this constraint, and then we solve. Okay, keep that. See the lambda change it to 0.95. Okay. Okay, this is how you. I will upload this file. It can help you to see how to do exponential weighted moving average to estimate the correlation. Okay, the dynamic correlation. Okay, once you have that correlation and the covariance, okay, so you take the square root, okay, square root of this estimated covariance, you see this one, okay, and you can have the I3 divided by the square root of the variance, okay, that's the correlation. So you get a correlation, and you can insert a graph. So you see the correlation between the dynamic correlation between the Australian dollar and euro. Okay, so that's the correlation graph. And same thing we can do is that I wanted to show you this one. We work on the question 11.5. Okay, 11.5 is going to be, you have daily volatility of these two assets, 1.6 and 2.5. The price of the asset at the close of trading yesterday was 20 and 40. And the correlation between these two is 0.25. Okay, the parameter lambda is for exponential weighted moving average is 0.95. Okay, and the price of trading day is going to change it to 20.50 and 40.50. So update the correlation. Okay. The first steps we do is that you can see the volatility and the correlation is using that the covariance. Okay, this is a numerator equal to the volatility 1.6%. Okay, this is a 1.6% times 2.5%. And times the correlation. Okay, the correlation is 0.25. Okay, the correlation, and this is the new covariance you estimate. The previous volatility or the covariance. So you get a covariance, and the price of the asset change it to 20 to 0.5 and 40.5. So you calculate the daily return. Okay, we did that. Daily return is going to be 20.5 minus 20 divided by 20. So this is a daily return for asset A, and this is daily return for asset B. Okay, the new covariance, how you estimate new covariance? Okay, we're using exponential weighted moving average, right? Okay, the new return, the new volatility is going to be lambda. Okay, so lambda is 0.95 times. Okay, this is the previous variance. Okay, which is previous variance 0.0162. Okay, and then we have 1 minus lambda. Okay, 1 minus lambda. Okay, and then you times 0.15. Okay, so that's we're using exponential weighted moving average for the new covariance. And then you use the same formula 10.8 to estimate new variance for SI A and new variance for SI B. Okay, and then you calculate the new correlation. Okay, remember the new correlation. The new correlation is the estimate covariance, okay, divided by the new square root of the new variance. Okay, so that's how you get the answer for 11.5. Okay, any questions? Okay, good. Okay, that's all for today. Well, I will upload this file. So if you don't understand, I'm going to you can take your time and to read my notes. And okay. 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 See you. Okay. The question for practice use of correlation. Okay. So if the high correlation is too powerful, it is not a good portfolio. It is so you wanted to good diversified. It's not diversified if the two assets have a high correlation.